Hello adventurer, welcome to Scratch Quest. Today is day 1 of learning math from scratch. I'm starting this series from scratch because my previous video, due to some reasons, due to my questions, I couldn't really complete this, and truth be told, I had missed a lot, maybe a month, maybe two or so, and due to that I have mostly forgotten those things, and that was a failure, but I needed to learn from the failure, and I have been running away from this very long. Again I fail, again. I hope this time I can actually complete this. Today's day 1. I'll be recording the video always. This is going to be a 1 hour video, screen record video, so there is no editing, just me speaking and learning. So I hope that I can be able to really go through this. Today is day 1. What we'll be doing is we'll be just skimming through what we have learned up to now. So we'll be skipping most of the part, as I have uh, learned up to day 7 or so, and I have learned most of the thing that something that I had learned was not that meaningful or not useless. It was useful in the case, but for me in this journey, it was not that much important for me to give it a day or two. So in this video, we'll be just skimming through the basic parts. So yeah, and sorry if there is any audio errors, any person speaking loudly, fans screaming or birds screaming. I'm not in a really good environment right now, so I'm not able to uh, be able to make a good video. Sorry for that. uh, I got really bad fever, so it's not a great way to start, but I think even if it's imperfect, I have to start someday. Today's day, so today's day 1 of math from scratch. So let's start. In today, let's start with the very basics. Numbers, the very foundation on which math is built upon. So numbers is basically what we have been counting: 1 2 3 4 5 6 7 8 19. It's a very simple concept. To understand what number really is, rather than just memorizing 1 2 3 4, let me tell you a little bit of history. So sorry for that. uh, so let me tell you a little bit of history. Numbers was originally invented in pre-farming era. So at first, when we human start evolving, then we used to keep cattle and stuff like that. So we had cattle like cow, goat, stuff like that. Let's take cow for examples. Let's say a shepherd called Sam had two cows. Now, how does he know that he had two cows? Without number, that is not possible. So Sam had two cows. He kept on breeding, and he had like many cows. But he don't know how to count because of numbers. But how does he keep track of them? How does he know which cow came home, which got killed by tigers, and something like that? To do that, what he used to do is he used to represent one stick to one cow. So he used to give one stick to one cow each. Then once when cow came from grazing, he used to like count the stick. If there was all stick, he used to know, okay, I have all the cow. If one cow was missing, then he used to throw the stick. That's how he used to keep track of the cow. That's where the basic of numbers counting came to place. The fundamentals of number is to keep count, to keep track of something, and it was posed, and this stick did the same. But let's say if there was thousands cow, if there is 5 cow, we could take 5 6 sticks, no problem. But if there is more than 100 200 cows, it's literally very hard to keep track with of keep track. You have to keep thousands of sticks in your in your positions. It's hard and difficult. That's where the concept of language number comes place. What do I mean by that? So numbers you see like 1, 2, 3 is basically a language. It is a language of math. Rather than saying two stick or representing three stick, writing three single line or three stick, you could just write this symbol or language. This is when normal language came to place. So if in Sam case there were thousand of cows, rather than write putting thousand of stick, he could just write these four lines of language, which was thousand. Now obviously not every country use 1 2 3 4. This is the English dialect and we use 1 2 3 4. In Spanish there is uno dos tres. In Hindi, in Nepali there we have ek dui tin, and so on. So this number you see is just a language to represent, to count. The basic of number is to keep track. Sam also used the numbers, but in a hard way. The number we are using is same concept of what Sam did, keeping track, but in an easier way. That's the concept of numbers. I hope you understand this. This is a very basic of numbers. Now numbers can be also be divided with. This is not that important, but a really simple concept. Numbers, there are different types of numbers. What do I mean by that? So numbers is from positive number from 1 to 100, and we have the negative number from -1 and infinity, and we have the zero in the middle. This is how number goes. But number can be categorized. The number is the same, whatever you say, the number is the same, but it can be categorized. For example, the positive number is called, just the positive number is called natural number, the number that starts from 1. The number that starts from 0 to infinity is the whole number. A number that consists of both negative and the natural number is called an integer, which contains the both. Now all of them is called a real number. So it is basically same number. The way we call it is just different. There are other numbers like real number or natural number, real number, and then rational number, irrational numbers, which is basically same, but which is number, but we have categorized them because in math, in situation of math, sometimes we can say let's use irrational number to do this calculation. Rather than saying this number, we can just say irrational number, whole number, to do calculation better. So it's just an easier method. That's why we are categorized. We have not, this is not the types of number, it is just categorized number, just broken down. So whenever we need to call a certain group of numbers, we can say it very easily. That's the whole point of categorization. This is the very basic concept of numbers. Now we have completed the base of numbers. Now we'll go to the concept of addition, subtraction, and division. So division and multiplication, which have multiple tree we need to learn from. This is before we go into the deep root of each of them, of how to do addition, subtraction, division, and multiplication in different ways, let's learn what they really mean. Addition, as it names some, we have all learned from the childhood. Addition means adding two things. Like if there is in a basket, if there is one apple and we add another apple, that is called addition. Now we have two apples. Subtraction means if there in a basket, if there is two apples, then we take out the we eat one apple, that is subtraction, taking out something. Division means, what does division and multiplication mean there? Okay, addition and subtraction means are very simple things. Adding means just adding stuff. Subtraction means just getting out of that stuff. And division and multiplication is really interesting in this stuff. We'll learn division and multiplication once we learn how to do subtraction and addition, because it gets more interesting. So in addition cases, So now now as we are learning this addition subtraction, I want you to remember this graph. This graph is called the life of numbers or path of numbers. I named this myself. At the middle path is the 0. It is like the balance sheet. As we go to the left, we have the negative number, the land of negative, -1, -2, -3, and so on. As we go to right, we have positive, 1, 2, 3, 4. Now in this graph you can also draw the middle line, but I will not be doing that for now. Excuse me. Now, so in the fun fact, first of all, let's focus on negative. Here in negative, which is bigger, -3 or -1? Most people in beginner math thinks is -3 is the bigger one because 3 is a bigger number, but that's not correct. -3 is actually smaller than -1. -1 is actually bigger than -1000, 1 -11, -1 million, because negative is negative. Smaller negative is bigger than a bigger negative. That's the concept here. So as we go to right, it gets more smaller, and as we go to right, it gets much more bigger. Obviously 1 is bigger, so 2 is bigger than 1, and 3 is bigger than 2. That's the concept positive. Now here's the interesting stuff. Before let's take the same example. Let's take Sam had an apple. Previously, when we said adding a number, what we used to do is, let's say Sam had 2 apples and he got 3 apples from Ram. Now what is addition? Addition means adding these numbers. 2 apple, he had 2 apple. Now adding, the symbol of adding is this sign, this plus sign, plus 3. Rather than writing 2 add 3, we could just write plus sign. So when you say 2 plus 3, how do we know is 5? There is two ways of knowing. First way of knowing is just what we did in pre-farming era, which is counting from first. So if you had 2 apple and 3 apple in the basket, you could dump all of them in one and count them from the very first. So 1, 2, 3, 4, 5. Oh, we have 5 apples. So what we could do is he could just pour that in a basket, pour the 2 apple and 3 apple in the basket and count from the very bottom. It starts from 1, 2, 3, 4, 5. No apple remaining, so 5 apples. That is what pre-farming era used to do, where number was not invented. But this is a huge problem, because this works only when there is few cattle, few apples, or few stuff. If there is 1,000, it's really mediocre to count from very beginning. It's hard. Sometimes we miscount something, sometimes we double count something, and much more errors. Rather than that, this addition that we used to do solves this problem. Rather than counting from the very first, we count from what we have. So we have 2a plus 3. So we see the 2 is what we have, the first number. So this is the first number, this is the first number is what we have. So 2 is what we have and 3 is what we have added. So when you say plus 3, we say add 3 apples. So count from 2 up to 3 times. So 2, after 2 count 3 times. 1, 2, 3. What number lies in here? So 3, 4, 5. 5 lies in the place, so 5 is the answer. Similar to this is this concept of path of numbers. In the path of numbers, let's say we have number 2. In 2 plus 3, we take 2 numbers. Let's take the position of 2. When we say plus 3, we go to the right. So we go to plus, we go to the right. How much position do we move? 3 position. So 1 2 3 5. So this is how we can use the path of numbers. Obviously this cannot be used every time when there is large numbers, as we cannot draw thousands of places, but this is a concept of how numbering works, how addition works. Similar to that is subtraction. Let's take 3 minus 1. First of all, I will teach you a concept. Wherever there is 3 minus 1, it doesn't mean 3 doesn't have any sign. Every number that is at front has a sign. If it doesn't specify what sign it is an addition. As addition is like the zones, it hides itself if not told. So if it is not told minus 3 minus 1, then the 3 is the positive, which is hidden. So the plus 3 tells us where it is, the position. The next sign to tell us where to go, left or right. Plus tells us to go to the right or left here, and the number that comes after it tells us which position, how much position it needs to jump. So when we say 3 plus 1, it goes at 3 position. Sorry, it is at 3 position and it needs to go 1 position. So 1 position, which is 4. Similar to that is 3 minus 1. It is at position 3. Now minus means go to the right, or go to the left side. So when it goes to the left side, it is at 2. Now here's the interesting part. What if it is minus 3 plus 2? Let's say we are in position minus 3. Position minus 3. So minus 3 means our starting position. Plus 2 tells us which position to go. Plus tells us to go to the left, to the right. So to the right. Let me clear one thing. Plus means plus and minus. Plus means basically going to the left, and minus means going to the right. Here is the clear thing. So minus 3 tells us where our position is. Plus tells us go to the left. Go to the left. So 2 position to the left is 1, 1, 2. We land in minus 1, which is our answer. So here is through this we can also learn an interesting fact. That is the sign rule. The sign rule tells us minus is equal to plus, plus minus is equal to minus, minus plus is equal to minus, and plus is equal to plus. Now plus is equal to plus, minus plus is interesting thing here. Minus equals plus. Does that means if we do minus 3 it equals to plus 6? No. This sign rule means when negative and negative is added, it equals to a bigger negative. So minus and minus 3 will equal to minus 6, not plus 6. There is a huge difference between plus 6 and a minus 6. So when we and similar to that, and minus and plus 6, and another rule through which, so when we do it minus 3 minus 2 plus 2, the rule says always take the bigger number sign. So if here, which is the bigger number? 3 is the bigger number. What sign does it has? It has minus sign. So sign will have 3. Sign will be minus. If it was plus, it would be plus. Similar to that, if it was 2 minus 3, it would be minus 3, because 3 is a bigger number and 3 had the sign minus, so it will be minus 3. So and a very interesting thing, minus 3 doesn't, when you say 2 minus 3 doesn't mean minus 3 is smaller than 2, what we have said before. Here it is subtraction, not a position it is telling. So in 2 minus 3, let's look at the position. So 0, minus 1, minus 2, minus 3, minus 1, 2, 3, 4. So let's justify this rule that whenever a bigger number has, whichever bigger number a sign number the bigger number has, the sign will be that. Here it is 2 minus 3. Here the sign of 3, the bigger number, is minus. It is 100% guaranteed the number would be a negative. First of all, we start with a positive. We are in position 2. The minus tells us to go to the right. Go to the right. How much position to go? 3 times. So 1, 2, 3. We land in minus 1. First thing proved. Let's say it was 2 minus 2 plus 3. 3 is positive, so its guarantee is going to be positive. We are in position minus 2. Plus 3 tells us to move 3 positions. So 1, 2, 3, 1. So positive 1. So we have proved few rules. First of all, minus minus plus just means bigger number. What does plus minus mean then? What does plus minus is equal to minus means? It just means the sign rule. So in 6 it just means that if there is, let's say, 6 plus minus 3, it just means it's going to be less than what it was. It will not never be bigger. So when you say 6 is a bigger number, it will be positive, but it is, we are still subtracting with something. So when you are subtracting, so plus minus means it's going to be subtracted. So plus is going to be smaller, so it's going to be 3. Yes, it ends up being positive, but the answer is still small. So plus minus means it's going to be small. It doesn't matter if it's minus plus or plus minus. Only when it is plus plus, it will give us a bigger number. So this is a result. Minus minus means bigger. Minus minus means bigger subtraction. Minus plus and plus minus just means it's going to be smaller than the smaller result, and plus plus means a bigger and plus plus means bigger number. Bigger number. I want to say I'm having fevers, Mr. So this is the basic concept of sign. We learned assignment to, we learned addition and subtraction. Now let's go to the next lovely stuff, that is multiplication. Multiplication is really interesting stuff. Most of my life I have really memorized the multiplication table but never learned what multiplication means. So here let's have a simple multiplication table of 2. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10. Let's go to here. Okay, so in this multiplication table, what does 2 multiply 2 means? What does 2 multiply 2 4? Why does 2 multiply 2 equals 4? What does this means? Well, multiplication is basically quick addition. What do I mean by that? Let's see here. So when we say 2 multiply 2 or 2 multiply 3, we're just adding to how much time? So when you say 2 multiply 2, we're just saying add 2 times. 2 plus 2. When you say 2 multiply 3, we just say 2 add 3 times, which will equal 6. When you say 2 multiply 4, we are saying 2 add 2 4 times. 2 6, 2 4 is 8, 4 plus 4 is equal to 8. See, this is what I didn't know. So multiplication is just addition but quicker. When you say 8 multiply 5, we are saying add 8 5 times. When you say 8 multiply 8, we are saying 8 add 8 times. So that is what multiplication is. This is the very core concept. Obviously, multiplication cannot be done always with through addition, but I wanted you to know what multiplication really is. Most people don't know and blindly believe the multiplication table. If you are really stuck in something, if you don't know multiplication table, do this. Add. So if you are given, obviously, if you are given a bigger number, you cannot do it. You need to use the concept of multiplication like this. If I give number, we used to do this. But here I'm just telling you this stuff to let you know what multiplication really is. And division is just opposite of that. Division is basically opposite of multiplication. It is the vice versa of multiplication. Let's take 2 divided by 4. It means, right? What does this mean? It means how many 2 fits in 4. Previously when we say 2 multiply 4, or sorry, let's say 2 multiply by 2, we say 4. We said how many 2 will give us 4. Now division tells us how many 2 is in the 4. The same concept but opposite of multiplication. In division, in multiplication we did 2 multiply 2 equal to 4, which just means 2 add 2 times will give us 4, and division means basically 2 divided by 4 will give us 2, which means how many 2's are in 4. So it is a reverse method. This is a reverse method of division. That's the reason when you take, let's say, division to another side, you will always see division turn into multiplication and multiplication turn into division. As addition is polar opposite of subtraction, multiplication is polar opposite of division. That's what this is. That's the reason when you take this is equal to means both things are balanced. It is the balance of world. We cannot say 2 is equal to 3. This is not acceptable in math at all. This is unacceptable. So when we say divide is equal to multiplication, so whenever division goes, let's say in a calculation, if there is division, you cannot just turn division into division. That is unbalanced. You need to make it the opposite. To balance the scale, you need to change the sign. That's why division turns into multiplication, addition turns into subtraction. It isn't done without any repercussion. It is done because of the fact that balance. In equal to sign, it must be equal. This sign, this must be equal. So 2 is equal to 3 never happens. When division goes to equal sign or balance, to take division to another side, division cannot be division, as it will create imbalance in equation. So that's why division turns into multiplication. This is a short note I needed to do, so I may remember this. So multiplication turn into division and addition is turned into multiplication and vice versa. Why? Because of polar opposite uh, attributes. So this is the basics of what subtraction, multiplication, division is. I really studied I say went into it to understand what this is. We have learned this basic concept of what number is, and what multiplication, division, addition is, but never really thought what they really were. So whenever I revisit this topic, it really amazes me of what math really is. From my perspective, this is one of the unique things about math. I always used to in equation, for example, in algebraic equation or any equation, I always used to think division used to turn to multiplication. We used to say minus minus equal to plus, but it used to never happen. We used to say plus if there is bigger number had a had a sign. We used to adopt that sign, but I used to never question why. And now, as I have learned math as my own and answered the question why, or asked the question why, it really amazes me of what math really is. Honestly, I'm afraid of math in many ways still now. Whenever I look at the advanced methods or math even of grades like 11, 12, those math are hard. But still, whenever I learn, it makes me feel really, really happy of learning this stuff. I hope even in advanced stages I can grasp the the basic concept of math. This was basic concept of addition, subtraction, division. Now let's do addition, subtraction, division in the format of addition. So let's say if there was a huge number from, and let's start from addition and subtraction. Let's say it was number, this number. Now addition is a really interesting stuff. If both of them are addition, it doesn't matter what order you keep it. I mean, it means it doesn't matter if you keep it in top or a bottom. It is the same because it will yield the same result. 6 and 6 will do well. Let's say 2 plus 4 is 6. It doesn't matter if 4 plus 6 6, 2 plus 4 is 6. So the order doesn't matter in here. But in subtraction it does. We'll learn why later on. So in here concept, you mean by saying what we are doing in here. So addition is, for at first in pre-farming era, it was done in a stick. Then we came forward, rather than counting from 1, we counted from where it started. We use the path of numbers, we understand the numbers. Now we are in the league of big leagues where we have to do calculation of huge numbers. Now how do we do calculation of this stuff? Now let's first of all go from the very first thing. Basic 43 plus 26. Order doesn't matter here, understand this. 3 plus 6 will give us 7, 8, 9. 3 plus 6 will do individual numbers. So we need in here the first concept, the first rule, the most right left number must match. So to the last number must match. So if it was 433 plus 26, it should be like this: 433 plus 26, and here it shouldn't be 433 and 2 and 4 be aligned here and 3 left out. It shouldn't be like this because of the rule called placeholder. I haven't talked about placeholder here. Placeholder is basically what number is, or the what it is basically the backbone of numbers. For example, 100. How do we know this holds the value of 100? How do we know that? How do we know this holds the number of 11? People say they have no value. If it is true, then 11 would be bigger than 100. Well, obviously not true. It has a value. How does it have a value? Because of placeholder. Placeholder means a number is basically a number that holds the place. It holds the place of a value. It holds a certain value. So previously I said the path of numbers had a certain path of numbers had is similar to the placeholder. What I mean is at the middle is a 0 again. At the right you got the negative. At the left you got the positive. Same. It's the same as 1, 2, 3, 4, but the place we have number that determines your placeholder. As you go to the right, left, the value increases by 10. As you go to the left, value decreases by 10, divided by 10, multiply by 10. At the first is ones, tens, then increase it by multiply by 10, 10 multiply by 10, 100, 100 multiply by 10, 1000. As you go to left, the value decreases, 1 by 10, 1 by 100, 1 by 1000, and so on. What do we mean by that? When placeholder, this is basically what it holds. It goes infinite and the value decreases as you by divided by 10 every time, and the value increases by 10 every time. So this shows you how number really works. So let's take 136 for example. Here tell me which number is the biggest. Obviously you will say 6 is the biggest number. Yes, true. Now let's tell me here which is the biggest number. You will tell again 6. Well, here is the different part. The 6th value that holds in here, the 6th of value that holds in here is very different. So this holds the value of 1. However, this holds the value of 100. How? Let's see. So in 136, it is 100 rupees plus 30 rupees plus 6 coins. So in reality, it seems that the 100 or the 1 we seen is basically 100, and the 3 we seen is basically 30, and the 6 we seen is basically 6. So no, 6 was actually the smallest number. So here we see the importance of placeholder. 6 holds the value of ones. Let's see here. Let's put them in place. When we say 636, we say 6. When you say 136, we show them. Sorry. 136, 136 is the number. Sorry. So when you say 136, we have, as we go to the right, we have we have 100, we have 10, and we have ones. We have multiplied them by the placeholder we have, we'll get the number 136. So this is placeholder. Placeholder, it holds a certain value. If without the placeholder, then in 136, 6 would be the bigger number. But due to placeholder, we know it is 6. 1 is a bigger number. Due to that, we know that 0 isn't worthless. 0 holds the value here. 0 holds the value of 10, and another 0 holds the value of 1. This holds the value of 100. Placeholder tells us what value it holds. It doesn't tell us what number it is, but what value it holds. How do you know 100 is bigger than 136? It has bigger numbers, right? But what if it was 100 is bigger than 86? It has 86, it has just 1. Due to placeholder, we know it holds the value of 100, and it holds the value of 10. So 100 is bigger than 10, so that's why it is bigger. I will be doing a much more deep explanation of placeholder. Now I cannot really explain it really in deep way. To give you a final summary, placeholder is basically of what a number really holds. We know it tells us what value or what number is actually bigger. In what we don't know if 736 or 726 is 786 is bigger or not. We don't know if 100 is bigger than 736 or not. Placeholder helps us to do that. We have been really far from what we have. So let us placeholder. Due to that reason, we cannot keep 400 when we do addition. We cannot keep 26. I'm gonna add 26 here because 2 holds the value of 10, but 4 holds the value of 100. We cannot add 100 plus 10 in here. That we cannot add number with different placeholder. So when we say 426 plus 26, we need to put it where its placeholder is. 6 is both the 6 are in placeholder of 1s, both the 2 is a placeholder of 10s. That's why we keep it in there. Similar to here, let's do the calculation of bigger number 423. 423 plus 526. Again, order doesn't match. 3 plus 6, 9. 2 plus 2, 4. 5 plus 4, 9. Simple. Let's say here nothing happened. It was 9 and 9. But what if it was 10? So let's take the same number but increase them one by one. 7 plus 3 will give us 10. Do we write 10 in here? Obviously no. That's where carryover comes to place, where 1 will be given the side number and the another number will just go down here. So when you say 10, the front number will be carry over. If it was 20, 23, 3 would be here and 2 would be carry over. Now you may ask how this is happening, how carry over is really working. Well, this method of addition is very simple really. This is just doing the same thing but differently. Rather than counting ourselves like 623, 627, let's do one thing. 623 is basically 423 is basically 420 plus 3, right? And 627 is basically 630 plus 7. Now let's add 3 plus 7. It will give us 10, right? So 420 plus 630. Now let's add 630. Let's 423 plus 637, right? 637. Let's divide this each of them according to placeholder. 400 plus 20 plus 3, and it is 600 plus 30 plus 7. Let's add the placeholder each of them. 3 plus 7, 10 plus 30 plus 20, 50 plus 600 plus 1000 is 1000. Now let's add them. It is 1050 or 1060. Let's see here if this would be the answer here. So 10, 5, 6, 10, 1060. So this is the same stuff but easier method doing. What we are when we are saying carry over, it is just a way of doing the same thing easier. Where when you say 10, you're just adding the tens. When you give 1 in here, 5, 6, we have 6. So see how it is working. So this is a beautiful method. Through this we can this method we can prove that how the method is working. So this addition which we are doing is just a method of adding. How addition really works is this way. Rather than doing all of them like adding each of making their procedure separately, we could do it directly in here. This is the region of addition. This is the same for subtraction. Only thing different from subtraction is that order matters. 423 plus 262, we cannot keep 262 up because let's see. First of all, let's do calculation. 262 multiplied to 423. 2 plus 3. 2 is already smaller than 3. 602. So when you look at this micro level, let's do the same thing here. 200 plus 600 plus 2, and we have 400 plus 20, 60, 20 plus 3. So when you do 3 minus 2, we have -1. When you say 6 minus 2, we have 4. And when you show 4 minus 2, we have -2. So we have -2 minus 4 minus 2 plus 4 plus -1. 2, 4, 2 would be the answer, -2. So that is why the reason we cannot do them. We cannot put the bigger number, smaller number, smaller of. So 3 minus 2, 1. 2 minus 6. Now we cannot do 4 in here because the upper number is smaller than bigger number. We cannot do that. So 2 minus 6 will result in -4. We cannot write -4 in here. So how do we prevent that? We need to get a positive number in here, in down here. To prevent that, we'll say, oh hey, give me a carry over. So we ask the neighbor for a number. So we get one number. But whenever we ask for neighbor, we can only ask to the left. Remember this in placeholder, the number we ask, the number as we go to the right, the value increases. So the value in this number is actually 10 times bigger. So we get, when we borrow one number from there, we actually get 10. So for it is just one number. But for another number, when it goes to the right, it is 10 from there. So we get 10 plus 2, 12. 10, sorry, 10 minus 6, 12 minus 6, 6. As we have taken one number, we have 3. So 3 minus 2 will give us that 161 is our answer. Now if we do this number, we'll get minus as the answer. So I have said you this, when we did 420, when we do 423 minus 263, I have told you addition is like a John Cena. It is always there. So when we did subtraction of this, we'll get the answer 161, which is a positive number. But if we had 4 minus 463 minus plus 263 is basically, well, yeah, you guessed it, a negative number, minus 161. So that's why it is recommended to put the positive number always up, or the bigger number always up. Obviously if the both number is negative, the answer would be the bigger negative. That's subtraction. Now let's do multiplication and division. Multiplication and division is really hard. Or multiplication is actually really interesting. So let's do 2 multiply 4, which is basically adding 2 times 4 times, which will give us result 8. This is a simple level, simples. Let's do 24 multiply by 2. How do we do it? Well, we multiply them each time. So rather than adding them to 24 times, what we can do is easier stuff. We can multiply each of them as a single one. So we can count them as single stuff. So 2 multiply 4 will give us 8. 2 times 2 will give us 4. The answer will be 48. So when we add to 24 times, we get 48, which is the answer. Similar to that, let's do a last number. 2 8 is 16, 2 2 is 6, 2 2 is 4, 5 would be added. So when you do 2 8 is 16, just like how in addition it would be carry over, similar to that it would be carry over here too. So let's say 2 2 is 4, 2 2 is 4. So 1 is the addition, 5. If it was 8, 8 would be added. 2 is 4 plus 8, 16, again carry over. So multiplication is cousin of addition, you can say. 2 multiply 4, 8. This is easier number where there is just one number. So we are multiplying a single digit with each of them. That's what we are doing, which will give the answer. What if there was two of them? Let's say 21. What to do? Again, first of all, just like how we multiply one at a time, we can multiply the bottom number to top number one at a time too. So two times. 4 1 is a 1, 1 5 is a 5, 1 4 is a 4. Now we can now it's round of 2. Again, here's the thing. 1 holds the value of ones and the 2 holds the value of tens. As we go to the right, we cannot just start just from here. We need to give 0 a place to till that is the start to till we are in next placeholder value. So if it was 121 and we did, so let's say first of all 2, the reason we added 0 was due to placeholder, just like how in subtraction, just like how we make sure that the numbers are aligned in addition subtraction due to placeholder, just like how in subtraction due to placeholder we know how to do, like which number to subtract. In multiplication too, due to placeholder, the number on is the number you see, like for example 2, we need to, as we go from there is two number, as we can see there is two number 21, we first of all did 1, there is in one position 458. Now we go down here, we have gone down here to signify that we are not in the position 1, so we need to add 0 till that we are in next position. This is simple thing. 2 4s are 2 8s are 16. We'll go in here. 2 5s are 10, 11. 2 4s are 8, 9. Now we have 9 1 6 0. So we do addition now here. This is the method. As we said, it is a cousin of that. 8, 11, 5, 5 6 and 9. 9 6 1 8 is the answer of 458 multiplied by 21. I hope you understand how to do this. The more number it is, if it was 121, what we'll do is we'll add another. First of all we have the 0 place again to signify we have skipped the ones place. 0 again to signify we have skipped the 10 place to skip. So we put two zeros. The first 0 has to tell to start from 10, as 2 is in tens place. We put 0 in here to signify, or we put as 2 is in tens place, we added 0 to start from to multiply from the start of the tens place. As in 121 1 is in 100 place, so we started from the 100 place. To start from the 100 place, we put 2 0. We can skip the putting 0, but to make it easier to add, we have to keep 0. Now it is division time. Division is a lot trickier than multiplication. There are different way of doing. For division, we need to remember about two things: remainder and remainder. There are two things. I hope you watched the video of Dr. Mike or something like that. His name was. His video is very interesting to watch what division side. Now division is a little bit tricky than others. So let's say we have number 2 and number 4. It's very simple. 2 2s are 4. So the result we get multiplied 2 2s are 4 will give us 4. The remainder is 0. So 2 divided by 4 will be 0. This is the answer. 2 is the remainder. When he said 2 divided by 48, it is 2 2s are. Let's say we don't know what is the division. 2 2s are 4, and we go down here 2 and we subtract. We subtract here. As we said, Addition is basically the coefficient of multiplication. That's why we do addition in last of multiplication. And similar to that, multiplication is coefficient to division. That's why we do subtraction in division here. So 4 minus 4, 0. It goes down here. Now it we do 4 the 8. 2 4 the 8. 8 plus 8 minus 8 minus 0, which would be, so the answer is 24. So 2 divided by 48 is 24. Yes, now that is simple method. What if there is two number 21 divided by 526, for example? Now how do you do this? This is pretty hard. This would be hard. We could do one number at a time. 21 minus 52 and stuff like that. For today I will be doing this much division. I will start from tomorrow from division. We'll be doing other division question too. Tomorrow we'll be covering all the basic stuff like fraction, fraction, percentage and stuff like that, and complete all the things we have learned up to now. Thank you for watching this video. Honestly, I will make sure to add caption and stuff like that. If there is any like gaps and any my voice being bad and not being clear, I'm really sorry. I will be trying to improve this later on. That's it for today. Meet you tomorrow in day 2 of math from scratch.